In this video, we will discuss about the glycolysis, that is an important topic of the biochemistry. The goals of this video is to basically understand that what is glycolysis, the location where the glycolysis occur, the steps that are involved in the glycolysis, the enzymes that are involved in the glycolysis, mnemonics to learn the glycolysis step enzyme in an easy way, and last but not least, we will discuss about the net gain of energy during the glycolysis. Now coming toward our main topic, that is glycolysis. First we will discuss about the definition of glycolysis, that is basically the breakdown of the glucose, that is 6 carbon compound, into the 2 molecule of the pyruvate, that is 3 carbon compound, and during this whole breakdown process there is a net gain of energy in a form of 2 ATP molecule. This whole breakdown process occurs in the cytoplasm and it is common in both aerobic and anaerobic respiration. Aerobic respiration that involve oxygen and the mitochondria, whereas anaerobic respiration that doesn't need oxygen and mitochondria. There are basically two phases of glycolysis. One is preparatory phase and other one is oxidative phase. We will discuss about these phases along with the steps of the glycolysis. We have already discussed that glycolysis consists of two phases. One is preparatory phase and other one is oxidative phase. First we will discuss about the preparatory phase. Starting from the first step, glucose, that is 6 carbon compound, is converted into the glucose 6-phosphate, that is also 6 carbon compound, and the phosphate group is attached on its 6th carbon. Glucose is converted into the glucose 6-phosphate compound in the presence of the ATP molecule. ATP molecule converted into the ADP and it gives the phosphate group to the glucose, which come and attach on the 6th carbon of the glucose molecule, and it forms the glucose 6-phosphate. This occurs in the presence of the enzyme known as hexokinase. Remember one thing, whenever there is a removal of the phosphate group or addition of the phosphate group, the enzyme that is involved in the certain step is known as kinase. So, glucose is converted into the glucose 6-phosphate in the presence of enzyme hexokinase or glucokinase, and in it the ATP is converted into the ADP and the phosphate group is attached on the 6th carbon of the glucose and form the glucose 6-phosphate. The second step is glucose 6-phosphate is converted into the fructose 6-phosphate. Glucose 6-phosphate and fructose 6-phosphate, they both are isomers of each other. They are the same molecule, different in structural composition. So the enzyme that is involved in this step is isomerase or phosphoglucoisomerase. Fructose 6-phosphate is converted into fructose 1,6-bisphosphate in the presence of enzyme phosphofructokinase. In it, ATP is converted into the ADP. It gives the phosphate group to the fructose 6-phosphate, which come and attached on the first carbon of the fructose 6-phosphate, and it forms fructose 1,6-bisphosphate. Again, whenever there is addition or removal of the phosphate group, the enzyme involved in a certain step is known as kinase. So, the enzyme involved in this step is phosphofructokinase. In next step, the fructose 1,6-bisphosphate is converted into the two 3-carbon compounds, dihydroxyacetone phosphate and glyceraldehyde 3-phosphate in the presence of the enzyme aldolase. Up till now, we have discussed about the preparatory phase of glycolysis, in which the glucose is converted into glucose 6-phosphate. Glucose 6-phosphate is converted into fructose 6-phosphate, and fructose 6-phosphate is converted into fructose 1,6-bisphosphate. Fructose 1,6-bisphosphate in the presence of the aldolase is converted into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. From now we will discuss about the second phase, that is oxidative phase, in which fructose 1,6-bisphosphate is converted into dihydroxyacetone phosphate and glyceraldehyde 3-phosphate. They both are 3-carbon compound with the phosphate group attached on the 3rd carbon. They both are interconvertible. Usually glycolysis utilizes glyceraldehyde 3-phosphate, so dihydroxyacetone phosphate is also converted into the glyceraldehyde 3-phosphate. Glyceraldehyde 3-phosphate is converted into the 1,3-bisphosphoglycerate. Glyceraldehyde 3-phosphate is 3-carbon compound in which the phosphate group is attached on the 3rd carbon. it is converted into 1,3-bisphosphoglycerate, in which one phosphate group is attached on the first carbon and other one is attached on third carbon. This occurs in the presence of enzyme known as glyceraldehyde 3-phosphate, the name of substrate, and dehydrogenase. Glyceraldehyde 3-phosphate remove one hydrogen atom from it and it converts NAD into the NADH, and glyceraldehyde 3-phosphate itself is converted into 1,3-bisphosphoglycerate. Remember, whenever there is a removal of the hydrogen group, the enzyme used in the certain step is known as dehydrogenase. The next step is 1,3-bisphosphoglycerate is converted into 3-phosphoglycerate. In it, one phosphate group is removed from the 1,3-bisphosphoglycerate. Only the phosphate group that is attached to the third carbon left. The removal of the phosphate converts ADP into the ATP. Energy is produced. Remember one thing, that whenever there is a removal or addition of the phosphate, the enzyme involved in a certain step is known as kinase. So, the enzyme involved in conversion of the 1,3-bisphosphoglycerate and 3-phosphoglycerate is phosphoglycerate kinase, name of the substrate and kinase. 3-phosphoglycerate is mutated or converted into the 2-phosphoglycerate. What happened in this step? That the phosphate group is shifted or changed its position from the third carbon to the second carbon. So, it is converted into from the 3-phosphoglycerate into 2-phosphoglycerate. So, enzyme that is involved in this conversion is known as mutase, phosphoglyceromutase. The next step, 2-phosphoglycerate is converted into the phosphoenol pyruvate in the presence of enzyme enolase. In it, water is removed. And in the last step and the most important step, the phosphoenol pyruvate PEP is converted into the pyruvate. In it, phosphate group from the second carbon is removed and it converts ADP into the ATP and energy is produced. And the compound 3-carbon compound form that is known as pyruvate. These same steps occur over here. Dihydroxyacetone is converted into glyceraldehyde 3-phosphate and it is converted into 1,3-bisphosphoglycerate and it is converted into 3-phosphoglycerate, then into the 2-phosphoglycerate, phosphoenol pyruvate and the pyruvate. So, 2 3-carbon compound pyruvate are produced. So, in the whole process of the glycolysis, one 6-carbon compound that is known as glucose is break down into 2 3-carbon compound that is known as pyruvate. Because the glycolysis consists of 2 phases, preparatory phase and oxidative phase. In preparatory phase, there is utilization of the 2 ATP molecule that are converted into the ADP molecule. We can consider these 2 ATP molecule as investment. In preparatory phase, there is no production of energy, no production of the ATP. But in oxidative phase, 2 ATP molecules are produced in this step and 2 ATP molecules are produced in the last step. So, 4 ATP molecules are produced. So, in the whole process of glycolysis, 4 ATP molecules are produced, 2 ATP molecules are utilized. So, we subtract 4 from 2 and hence the net gain of the energy is 2 ATP molecule. And in this step, the 2 NADH molecule are produced. Now, summarizing the net gain of the glycolysis, in preparatory phase, the 2 ATP molecules are utilized, whereas no ATP molecule are produced. In oxidative phase, ATP molecule utilized are 0, whereas the ATP molecule that are produced are 4. Net gain is 4 minus 2, that is 2 ATP molecule are produced in the whole process of glycolysis along with the 2 NADH molecule and 2 3-carbon compound that is known as pyruvate. So, glycolysis is 10-step pathway that cause the breakdown of the glucose, that is 6-carbon compound, into the 2 pyruvate that are the 3-carbon compound along with the production of energy in a form of the 2 ATP molecule and 2 NADH. subscribe my channel, like my video and also share it, and also follow my Instagram page, that is Medicine All in One. Thank you.